Gosh, I've got to do something for you guys tonight. Send out your results. Not ready for that. That's not what I want. Oh, good. The Zoom lesson's finished. All right, before we begin, are there any questions? Can somebody please confirm you can hear me okay?
I can hear you.
Thank you. Let me share my screen. Got one too many there, but we'll get that later. So today is May 14th, and we are supposed to be covering Lab 8, identification of gram-positive organisms. Hopefully, sometime later tonight, probably late tonight or early tomorrow, meaning after midnight, I will send out your first results on the unknown project, which will be giving you your unknown number and the results for the gelatin hydrolysis test, the gram stain, and the PR test, or the PR lactose test for your unknown species. You should take that information and at the very least put your unknown number in your unknown notes pages. And then you should also put your results from these 3 tests in your unknown notes pages. And then when you're all done, take a look at the table of the unknown, meaning the unknown species, and try and figure out which test to ask next. And then put that in your unknown notes page. Any questions on any of that? All right, so let's begin Lab 8. I had it here someplace. I think it's this one. Yeah, Lab 8, identification of gram-positive organisms. We're going to be looking at gram-positive cocci, specifically the Staphylococcus, Enterococcus, and Streptococcus, those families, as well as some gram-positive bacilli. We'll briefly look at Listeria, more likely look at Clostridium, I'll briefly Corynebacterium, and Bacillus. There are some supplemental materials in the lab today. You'll be doing a video clip. You'll also be using a gram-positive dichotomous key, and there are some case studies to do in today's lab. Any questions about what we're going to be doing? All right. Upon successful completion of this lab, students should be able to understand the principles and how to interpret the results for the CAMP test, the bioesculin test, the SF broth test, and the optogen sensitivity test. You should also learn how to use the dichotomous key to solve case studies involving gram-positive bacterial infections. Let me mention that for the dichotomous key that you're using in today's lab, it should only be used for this lab. It should not be used for any other lab, nor should it be used for your unknown project. Any question about any of that? All right, when specimens are received in a microbiology lab for routine bacterial culture, they're inoculated on a culture media that will facilitate the growth of common bacterial pathogens placed in a physical environment to support their growth. Microbiologists can use colony morphologies and the gram stain to provide important information about the primary classification of the bacteria that they isolate. However, identification will require further biochemical tests. In this lab, we're going to look at the CAMP test, the bioesculin hydrolysis test, the SF broth test, and the optogen sensitivity test. Any questions about what we're going to cover? All right, the CAMP test is a test which is an acronym for three microbiologists' names, Christie, Atkins, and Munch Peterson, and that's where CAMP comes from, who first described the amplified hemolytic effect that some beta hemolytic organisms have when they physically grow near Staphylococcus aureus. To do the CAMP test, you take a plate and you do a single streak of beta hemolytic Staphylococcus aureus down the middle of a blood agar plate. Perpendicular to the staphylococcal streak, you make another streak with the test or unknown organism. And then you look at the hemolytic enhancement to see if there's any hemolytic enhancement of the test organism growing near the staphylococcal aureus streak. Any question about any of that? All right, so here's the CAM test, and there's the streak of Staphylococcus aureus, put down the blood agar plate, and then we streak Streptococcus pyogenes this way, perpendicular to the Staphylococcus aureus. And then you look to see, is there any enhancement in this region here? Streptococcus pyogenes has no enhancement of beta hemolysis. Let me show you a blow up. Staphylococcus aureus is very easy to see because it grows very distinctly and very copiously. So we have the streak of bacteria shown here, and then around it, the lighter area is the beta hemolysis from Staphylococcus aureus. On Streptococcus pyogenes, we have a very skinny streak here. Streptococcus pyogenes doesn't grow big colonies. And then around it, we have beta hemolysis. That's the lighter region. So there's the blood, it's red, and there's the bacteria. I don't know what color that bacteria is, but it's the darker region. And then we have the lighter region. The lighter region is beta hemolysis of Streptococcus pyogenes. And we have no enhancement of the beta hemolysis of Streptococcus pyogenes near the Staphylococcus aureus. Any question about any of that? So that would be no enhancement, no CAMP reaction, negative CAMP. And then you're going to have the next one. Let me see how I can get over there. Where we've streaked Listeria perpendicular to Staphylococcus aureus. And there you can see the Listeria and a very, very skinny beta hemolysis around Listeria. And there in this region here near Staphylococcus aureus, we see slight enhancement of the beta hemolysis by Listeria when it is grown near the Staphylococcus aureus. Any question about any of that? And then we have Streptococcus agalactia, which there's the bacteria here, there's the beta hemolysis, and then here we have great hemolysis, enhanced hemolysis, when Streptococcus agalactia is grown close to Staphylococcus aureus. Oops. And you can note that in the CAMP test, the enhanced hemolysis usually takes on an arrow-like appearance. Same with that. It's a very small arrow, but it's an arrow. So the enhanced hemolysis shows you an arrow-like appearance of the hemolysis. Any question about any of that? Anyways, that's the CAMP test. Let's move on to the bile esculin hydrolysis test. Bile esculin is in an auger slant, and when it becomes positive, the bile esculin will turn black or very dark brown. Bile esculin is used to differentiate Enterococcus from Streptococcus species. If the organism hydrolyzes esculin, esculatin will be made, and this is a very dark brown, black precipitate. If you see 50% or more of the tube, dark brown or black, then it is bile esculin hydrolysis positive. And it is, an example is a positive is Enterococcus species or positive. All Streptococcus species, meaning all members of the Streptococcus species, are negative for bile esculin, the bile esculin test. Any question about that? All right. The SF broth test is called SF broth test after Streptococcus faecalis. In the old days, like before in 1980, Streptococcus faecalis was the name of the species. But after they did DNA sequencing on the species, they came to realize that what they call Streptococcus faecalis is not in the Streptococcus family, and they changed the name to Enterococcus faecalis. But the test is still called the SF broth test after the old name Streptococcus faecalis. Any question about any of that? All right, SF broth contains a pH indicator, almost screw purple, and it's purple in color. If the bacteria like Enterococcus can grow in the presence of sodium azide and then ferment the sugar in the tube, it will change the color from purple to yellow. And that will be a SF broth test positive, which, as I mentioned, Enterococcus faecalis is SF broth positive. Streptococcus species, meaning all the members of the family Streptococcus, are SF broth negative, so they will retain their purple color. They either do not grow in the SF broth or they do not ferment the sugar. And that's the SF broth test. Any questions? Positive, negative. The optogen sensitivity test is testing for optogen sensitivity, which is an antibiotic, and it's used to differentiate Streptococcus pneumoniae from other alpha hemolytic streptococci. So if you streak streptococci on a blood agar plate and you get alpha hemolysis, it could be Streptococcus pneumoniae, but it could be another member of Streptococcus family, which is also alpha hemolytic. And what you do is you grow this bacteria in this region of a plate and then stick on the disc containing the antibiotic optogen, and then you look to see if the bacteria is sensitive to the antibiotic optogen. If the bacteria is not sensitive to optogen, then it is not Streptococcus pneumoniae. So it is some other form of Streptococcus, which is alpha hemolytic. If, on the other hand, the bacteria is sensitive to the antibiotic optogen, then there will be a zone of inhibition around the disc, and that zone of inhibition has to be greater than or equal to 14 millimeters in order to be sensitive to optogen. And if it's an alpha hemolytic streptococcus family, then we know this is Streptococcus pneumonia. Any questions about that? Now note, to be resistant to optogen, you simply need to have the zone of inhibition less than 14 millimeters, down to no zone of inhibition, and no zone of inhibition is shown. Any question about any of that? So optogen resistant can be 0 to, let's say 13 millimeters in the zone of inhibition. But if it's 14 millimeters or greater zone of inhibition, then it's sensitive to optogen. In summary, there are a variety of biochemical tests to aid in the identification of unknown bacteria. Microbiologists utilize a dichotomous key that helps them identify their species for their test results. An example of a dichotomous key is shown here using dichotomous logic. So here we have all possible bacteria, and we can separate that into gram-positive and gram-negative. If it's gram-positive, we then scratch these out. And if it's gram-positive, we can then characterize the gram-positive cells into gram-positive bacillus or gram-positive cocci. If it's gram-positive cocci, we can then split the gram-positive cocci by doing the catalase test. If it's catalase positive, it's going to be a Staphylococcus species. If it's catalase negative, it's either gram-positive cocci, the Streptococcus or Enterococcus. So if it's gram-positive catalase positive, we can cross out the negative and then separate the Staphylococcus species by doing the coagulase test. If it's coagulase positive, it'll be Staphylococcus aureus. And if it's coagulase negative, it's some other member of the Staphylococcus family, like Staphylococcus epidermidis or Staphylococcus saprophyticus. And then you can separate those two by running the novobiocin test. If it's novobiocin positive, meaning you successfully, I don't know why that's broken up there, you've successfully gotten a zone of inhibition around the novobiocin antibiotic, then it's Staphylococcus epidermidis. If, on the other hand, it's novobiocin resistant or negative, then it's Staphylococcus saprophyticus. You can note that as we were going down here, we split all previous things, like all cells here, into gram-positive and gram-negative. And then we did another test splitting it into bacillus and conchi. Did another test splitting the conchi into the catalase positive conchi, gram-positive conchi, and the catalase negative gram-positive conchi. And this is using dichotomous logic to run these tests. And then we got a key. Let me see if I can find that. For identifying the species, which actually it's here. You come down here, you identified it either as Staphylococcus saprophyticus or Staphylococcus epidermidis. Any questions about that? This key is a little different, and that is it's showing you exactly how the key is when you're running the test. Let me show you another example of the key. This would be the dichotomous key you're using for this lab. So here we have the gram stain, and if it's gram positive, then we can split that into the gram positive conchi and the gram positive bacilli. Cross out the bacilli because we have gram positive conchi. You can then split that with the catalase test and the catalase positive, the catalase negative. Cross out the catalase negative. I can't get that to move. Don't want it to move there. Then we have the catalase positive, and that'll be Staphylococcus. We can split that in the coagulase positive and the coagulase negative, etc. Note on this key that you're using for this lab, you got a second page here, and it will follow the gram positive bacilli. Any questions about any of that? All right. You shrink that down a little. In lab 8, you're not physically going to be performing any of these activities. However, you will be held responsible for knowing how to perform and interpret these tests. We have 2 video clips on both the SF broth test and the bile-esculin test in the first video, and then a second video showing you the CAMP test. So watch those videos before doing the lab, and then review how to interpret the following tests by completing the chart. And I believe we should go to the worksheet now. Remember, turn in the worksheet, not the lab module. And some of you will get a penalty if you turn in the lab module. So make sure you don't turn in the lab module. So in this table, fill in the results for positive result and negative result. The first one has been done for you. The gram stain for conchi and bacilli. The positive result, the cells will be purple, gram positive, gram negative, these cells will be pink. So do that for the Schaefer-Fulton stain for endospores, the negative stain for capsules, the catalase test, the coagulase test, the oxidase reagent, the CAMP test, the bile-esculin test, the SF broth test, the optogen test, and then optional, the basotrace sensitivity test. I've got that in there because you need to know about the basotrace and sensitivity test to answer one of the lab questions. I think is in the case study. Next term, I think I'll make that required, but at the moment it's still optional. So put those in. Some of the tests, the optogen, SF broth, bile-esculin, the CAMP test, you can get the results from this lab. So you can look up the results from this lab module. The other tests, You either have to look it up from a previous lab or you can look online for what the positive result will be and what the negative result will be. Any question about that? All right. And question 3 is to view the video on how to develop a dichotomous key. So just click that link. You're not going to be constructing a dichotomous key for this class. However, you need to know the general idea behind such a key and then how to use such a key. And then please open the dichotomous key file for the lab. There's 2 pages in the file. I already had that open, but let's go get it again. You'll need to use this to answer some of the questions in the lab. Oops, that's not right. Where do I want to go? These are the species of bacteria we're going to be looking at in this lab. And it continues on the next page. For number 4, use the 2 dichotomous keys provided in the files to identify the gram-positive bacteria causing the infection in each case study. The case studies will be a file in Canvas that you need to open for Lab 8. Let me go there. There you go. So besides, in this case, the lab module and the worksheet, you're also going to have to open up 8 case study files, as well as the dichotomous key. Let's only look at case study 1 and I'll begin that one. Actually, I have a better way to do that. Case study 1, let's close that. All right, a 13-year-old teenager shown here attended a week-long summer camp. Upon returning home, his mother notices a pustule beginning to develop on his arm. It looks like a spider bite. The area is warm to touch and is becoming extremely painful. When her son starts running a fever, she takes him to a walk-in medical clinic for evaluation. The physician orders a gram stain of the exudate and a routine culture. Here are the findings. Here are the bacteria cells here. These are the boy's cells, so don't look at those. Let me blow that up so you can see it better. You can actually see the cells there, what shape they are and what the gram stain is, as well as the cell growth arrangement. And then this is the bacteria grown on blood agar. And as you can see, something's happening here. This doesn't look like a friendly bacteria. You can determine what the hemolytic activity was. Let me shrink this down now, show this better. And then they took the cells from the blood agar and put it on this rapid slide test. I'll tell you what this test is. Adding hydrogen peroxide, that's a catalase test. And there's the results of the catalase test. Let me shrink that down a little further. They then took some of this bacteria and grew it on a mannitol salt agar plate. You can read about mannitol salt agar in the lab on Canvas. in the previous week. I think it's week 5 of the lab, what it means. And the bacteria has changed color. The mannitol salt agar has changed color as well as is grown on the mannitol salt agar. And that means that only certain bacteria can grow on mannitol salt agar. You can find out what that means and then what the color change means. And then identify the bacteria from these results and give me a species name. Put the species name in the case study 1 right here. Okay, any question about that? Let me mention in case study 2 and case study 3, it has test 2. Test 2 is the basic trace and sensitivity test. So let me go ahead and just briefly look at that. I'm not going to read it this time what the case study is. But there they grow the bacteria up. You can see the hemolytic pattern there. And then they're doing the catalase test where that's shown there. And then this is test 2. Like I said, that's the basic trace and sensitivity test. And as you can see, there's no zone of inhibition around that basic trace and disc. And then we're looking at the CAMP test right here. What bacteria was isolated. Any questions about that? All right, so go ahead and get started on lab 8. I'll be here until 8:30 to answer any questions. I'll be here longer if people need me, but lately people have been logging off early, so I'll say for sure I'll be here to 7:30, but I will leave once the last student logs out. Oh, and let me remind you, you need to open up the lab module, the lab worksheet, and then each of the case studies, there's going to be 8 of them, as well as the dichotomous key. And let me also remind you, the infectious disease research project is due this Saturday at 11:59 p.m. May 18th. And this is a 100-point project. I think there are a few students who still have not cleared with me what their project's going to be. So if you need to clear with me what your project can be, you cannot simply choose a topic. You have to choose a topic that I agree with and one that somebody else has not taken. Otherwise, you'll get a penalty. Any questions about anything? All
I have
right.
a question.
Yeah.
You may have already answered it because I attended the Zoom meeting late, but do you approximately know when we will get our unknown number assigned?
I will send that out hopefully late tonight or early tomorrow morning.
Okay, thank you.
Okay. That's my plan. Hopefully I'll get it done. All right. Any other questions?
I have a question.
Uh-huh.
On number 3, we're not supposed to be like typing out anything, right? It's just going over the video and looking at the
The
key.
dichotomous key, yes.
Okay.
Yeah, there's no question to that one.
Okay. And then I don't know if you'd be willing, on case study 5 is it to me provides 2 possible answers.
No, there's only one, I'm sure of that.
That's what I thought too. Would you be willing to look at it, or
I will take a look at it.
it's the same strep, but to me it's confusing at the end result.
Case study 5, you said?
Yes.
All right, a 38-year-old female, a history of methamphetamine addiction, major dental work, really bad. She has a low-grade fever, later on increasing malaise, signs of mitral cardiac valve anomaly, Her condition progressively worsens. She is admitted to the hospital for evaluation. They do 3 blood draws. The next morning, one of the blood cultures, broth, is cloudy. We don't see that here, but we'll take the word for it. And then they look at the blood culture and you can see bacteria growing in her blood. Or at least we find bacteria in the blood. It's probably growing in the blood. The broth is gram stain and subcultured onto blood agar plate, BAP, and there's the growth on the BAP. You can actually see the hemolysis there, although you have to blow it up probably. Let me see if I can blow that up. Scroll down and over. There you go, right there. You can see the, yeah, even right there. You can see the hemolytic activity. Oops, went too far. Let's go on over here and go back to here. They then took the bacteria from here and let me shrink this down now. Did the catalase test. There's the results of the catalase test. They then did some other tests. That's the optogen sensitivity test.
Mm-hmm.
This is the SF broth test. And there's the biolisculin agar test. Okay?
Yeah.
So, what did you get for
So it, obviously
blood agar? What'd you get for the hemolysis?
that's negative
And that's
because
not
there's
correct.
for, sorry, what the,
Optogen sensitivity is negative.
yeah,
SF broth is negative.
yeah,
Biolisculin agar slant is also negative.
yeah.
But the blood agar is not negative. I just blew that up. Let's see if I can blow it
Oh, well,
up.
that one's not negative, but the, with the actual test they were looking, the labeled test below is what I was looking at.
No, I'm talking about what hemolytic activity is that? It's not negative. So what hemolysis is this? It's not negative, so it's not gamma hemolysis. Well, is it beta hemolysis? All right, think about it. All right. And maybe that's what's getting you off, that one there. So when we come to the key, let me see if I can get the key back up. I even have it here. There we go. The bacteria, can you tell me the shape?
Of, oh, is the catalase negative?
I asked for the bacteria shape.
A cockeye.
Cockeye, okay. And it is catalase negative.
Mm-hmm.
And yeah, this is where you got wrong. You didn't get the hemolysis correct. This alpha, gamma, and beta is hemolytic activity.
Yeah.
And you went in gamma, and that's what you got wrong. Okay? All right, is that enough to help you?
Yes, thank you.
All right. All right, let me, did I shut the Zoom down? Ah. Oh, there it is. Stop the share.
I have a question regarding our unknown project.
Okay,
So I know like to write the paper, the questions like do I have to answer all of the questions like what is the causative agent of the disease? And then if it's a virus, what is characteristic? Are there any unique character? Do I have to answer all of those, or it's just like something that helps us with our
if you have a virus, then you should answer all of the questions about viruses. But obviously, if you have a virus, you would not answer anything for a bacteria, for example.
Mm-hmm.
Okay,
Okay. Yeah, that makes sense. All right. Thank you.
right.
Uh-oh.
All right, let me stop my recording if I can get that. Zoom is difficult to work sometimes. Ah, here it is.